Hi. In the last video we looked at proof by induction. Today I'd like to do, in this video, another proof by induction, slightly different than the last one. So what I want to look at is I want to show that 8 to the n minus 2 to the n is divisible by 6 for all n greater than or equal to 1. So I first need to do the base case of n equal 1. And I have 8 to the 1 minus 2 to the 1, which is 6, which is, I think, clearly divisible by 6. So the base case checks. Now, I need to assume that 8 to the k minus 2 to the k is divisible by 6. And I need to show that 8 to the k plus 1 minus 2 to the k plus 1 is also divisible by 6. All right, so how do I go about doing that? Okay, so how do I go about doing that? Well, I'm going to rewrite this as 8 times 8 to the k minus 8 times 2 to the k plus 8 times 2 to the k minus 2 to the k plus 1. Now how did I get to do that? Well, this part right here is just 0. I subtracted 8 times 2 to the k, and I added 8 times 2 to the k. So here's my original 8 to the k plus 1 minus 2 to the k plus 1, and then I added 0. And so I'm using that property that adding 0 to any number doesn't change the number. And now I can write this as 8 times 8 to the k minus 2 to the k plus 8 times 2 to the k minus 2 times 2 to the k. Because that's what 2 to the k plus 1 is 2 times 2 to the k. And then I noticed that this part is just 6 times 2 to the k. And this is still 8 times 8 to the k minus 2 to the k. And by assumption, this part is divisible by 6. And so 8 times something that's divisible by 6 is divisible by 6. 6 times something is clearly divisible by 6. And so if I have something that's divisible by 6 plus another thing that's divisible by 6, then the whole thing, so this is divisible by 6. And I'm done with my proof by induction. So this was a little bit different than the one we did previously, but still done by induction. So once again, we start with our statement. We check the base case. We assume up to k. And then we have to show that it's also true for the very next step. I hope that this helps clear up how to do proof by induction.